Hello guys and welcome back in the Robyn tutorial series. I'm your host Christian and today is kind of like a special day. In fact, in this video we will not cover any kind of Robyn functionality or feature specifically, but we will go through a real world scenario using Robyn. Since the production of this series we have received a lot of requests to record such a video, and finally we found a project which we thought that suited this kind of video pretty well, because as you can see we run 5 different models until we got to a model that we are somewhat happy with. So I will show you all the thought process and workflow and the modifications that we do and we did to the model specifically in order to optimize it and make it as close as possible to a model that made sense both statistically and business wise. And before starting, I would like to point this out, that as of today in Robyn and in general in marketing mix modeling, there is still a lot of human bias, because you need to basically supervise what the model is doing, and you need to do feature selection mostly by yourself and try to understand whether or not the model makes sense, not only statistically but business wise as well. So you may not agree with some of the thoughts and modifications that we did and chose to pursue it basically during this modeling phase. Feel free to share your thoughts, to give us feedback, because this is basically how we do it, but probably and most likely there's someone out there that's better than us, knows more than us, and so we are more than happy to keep learning basically and share feedbacks with everyone. So let's start, but before showing you the models I would like to give you a little context about this customer. This is a business that does shipments, so they basically have this kind of web app where people can buy the shipments, and then they will arrange the shipments and handle all the logistics and stuff like that. Okay, so this is one thing that I would like to specify, is that we chose to create a daily model because this business varies a lot between weekdays and weekends. So basically from Monday to Friday they have much higher volume in terms of sales, while Saturday and Sunday get way less sales, because most likely most of the business that they work with are closed on weekends, because they work with a lot of local shops and stores, and on those days there are pretty much no shipments going on. So the amount of people buying shipments on the weekend is a lot smaller basically. Okay, and the first thing that I would like to show you, I'll move myself on the bottom right, is the data set that we are starting with. And it has approximately 1.5 years of data. We are starting from July 2020 down to the end of May 2022 basically, and end of April. And like I said, this is daily data because it represents the business a lot better. And the things that we have here that we could use as independent variables is revenue, transaction, or number of new customers generated per day. Specifically in this model we chose to go with new customers because we had the chance to run a geolift experiment with this customer, but we had to specifically run the geolift experiments to measure how many new customers we could bring with a new acquisition channel. And for this reason, we had this experimental data that we wanted to test out. So we decided to build a model which will work on new customers, and to add the calibration using Robyn, of course, to the model specifically on this variable. But I will show you that in a little when we will review the code that we use to run the model. In addition to that, we basically have our Google splitted by campaign type. So we have Google search spend and clicks, Google display spend and clicks, Google discovery spend and clicks, performance max, and then we have a Google others, which is basically a bunch of other campaigns that are not specifically divided into any of the previous groups, and so we group them up into a Google others kind of column. In addition to that, we have Facebook spend and impression, which are aggregated and not splitted by maybe retargeting and prospecting or anything like that, simply because we don't do much spending on Facebook. This business is really the amount of basically impact that Google has on this business is much higher than what Facebook can do. So we do advertising on Facebook, but it's much smaller spending. So we chose to aggregate that in order to be more relevant basically in the model. And then we have Bing, which is a channel this specific client used to advertise on until I believe the mid 2021. Basically in the second half of 2021 they decided to shut down Bing because they thought that Bing didn't have an impact on their business, and in fact not so much changed after they had turned off Bing. But in that period, there was iOS 14 that has been released, so it was kind of tough to properly attribute basically what was going on into different channels. But anyway, they chose to turn off Bing, and now we are looking for ways to bring more. Bing is Microsoft Ads, if you're not familiar, and now we are trying to find out ways where to bring more new customers to the platform. And so we decided to do this geo-lift experiment with Bing, where we turned Bing on again in half of Italy. And we saw actually an increase number of new customers. Specifically, I believe it was around 88, but we will see that later. So the experiment was actually cool, and we decided to test how this experiment would help calibrate the model. In addition to that, we have a couple organic variables, specifically organic Bing sessions and organic Google sessions, and then session from referral and from email. And the last thing that we tried to include is a context variable, which is simply the exchange between Euro and USD each day, per day basically, because while this is a client operating in Italy, the shipments may go and come from outside Italy. So we try to figure out whether or not the exchange in Euro and the USD would have an impact on our model. And so starting from this dataset, basically, the next thing that I would like to show you is the R file. And it's really simple. The process that we use usually is either start from the demo R file that you can get from the Robyn GitHub, or otherwise we will start from another file from our clients that are already customized. But the code is really simple. We simply import Robyn, then reticulate. We set up the multi-core and use the virtual environment from reticulate, which in our case is our reticulate Cassandra. This may vary in name, or you may be using Conda, so this specific 2 lines of code may be a little different for yourself. We import the Prophet Holidays dataset and set up the Robyn object, and then we set up all our inputs. And as you can see, we are reading the CSV that I just showed you using holidays. Our date variable is order date, and in this case, since Robyn must know whether we are doing conversion or revenue, and since we are using new customers, we used conversion as the type for Robyn, simply because it's more correct to let Robyn calculate the CPA over the ROI, since the CPA in this case will basically be our customer acquisition cost instead of cost per order. So we set the type to conversion and the vendor variable to new customers. Then we did a first test where we basically included everything, okay? So we put the context variables, which is Euro USD exchange. We put profit to IT with all the variables possible. We set up all our paid media values and expense and all the organic variables. And specifically, we decided to include the a rolling window, which made sense in terms of the client specifically, because after May 2021, they had quite a few changes on their platform. So the customer experience changed a lot, and we decided to take this kind of time frame to better represent their business. We use Webull PDF ad stock since it's most likely the best one, the more comprehensive one in terms of what it can help describe, because it enables to have both variable decay rate as well as lagged effect. So overall, while it's more time consuming to run, basically, it's usually the best one to go in order to describe reality as best as possible, basically. Then we keep the plotting to false, since we don't really mind to analyze the plotting during this kind of first executions, basically. We set up all the hyperparameters. Usually we leave the recommended boundaries from Robyn as default. And then whenever we have some troubles, maybe the model is not converging too much, we will try to enlarge the boundaries and then put more iterations and trials, so that Robyn has more freedom basically to choose, but as well as more time to try and figure out what's working best and what's not. So in this case specifically, we kept the boundaries, the recommended boundaries. Then we set everything into input collect using Robyn inputs. And this first time, actually, we tried not to run with calibration. So you see here the code for calibration. I'll talk about this, but I will show you two models which are built exactly the same, one with calibration and one with not, so we can see the difference in what's happening, basically. And to set up the calibration, as we have seen in our previous video, actually, the thing that you need to do is set up the channels that you have done some experimental calibration on, and specifically our channel is being spanned, and then select the start date and end date for your experiments, which in our case was only 5 or 4 days, basically. So for from April 11 to April 15. Then we need to set up the amount of lift that we generated from this experiment. In our case, in these days, we generated 80 additional new customers than usual, because before the experiment, you need to evaluate how many new customers will come anyway. Then you run the experiment and measure the lift, basically. But this is something that's more related to how to do geo-lift or conversion lift. So anyway, you set up the lift that you found out during the experiment and the total spend in terms of dollars or euro or whatever you're using that you spent into this period. And of course, this number of spend must match what is inside your CSV file. So the CSV file must contain the spends in the period of the experiments, as well as the related impressions or whatever. And then the confidence, which in our case is our p-value, and specifically in this experiment it was 98%. And then you need to specify again the dependent variable that this experiment was measuring, in our case new customers, of course. Then you can update the Robyn inputs using again Robyn inputs, but this time you will pass calibration input instead of the hyperparameters that we set here. And then we can move on to Robyn run. And specifically, since we wanted to have kind of a quick run to get an idea of how the model would work, we decided to set 5,000 iterations and 5 trials. Then you can check out your convergence plot and decide whether to keep such number or maybe go a little higher. We will usually increase this a little up to probably 10,000 and 10 trials if we have some time to generate the final best model usually. And then you simply do, we rather do this splitted basically, so we set output false first in the Robyn run, and then we do Robyn outputs with one period of runs and everything else, basically clustering true and plot Pareto true. And so here you can see the very first result from the code that I just showed you without the calibration. And as you can see, basically this business, I was telling you that they sell a lot less during the weekends, and that's why you see so much variation. However, Robyn managed to get this variation pretty good. In fact, the R-square is 85% in this one specifically, and all these models are pretty much similar, I would say. But as you can see, there I'll show you this one just to go quicker. They are really similar to each other, but there are a couple of things that we don't really like into this model. And specifically, the thing is that we don't believe that 25% of our conversions, or even more in other kind of iterations, can be attributed only to the exchange between euro and USD, and another 25% to the trend. That will mean that more than half of our conversions in total, considering the intercept as well, will basically be attributed to variables that we don't really have control over at all. And for experience, for the knowledge of our business, we know that's not true, because we can see a lot of variations based on our Google spends, for instance. And another thing that we didn't like too much is this organic Google that has 0% of impact on sales, basically, of attributed sales. And that's not true, because we know for sure, we have done tests in the past, and we know that organic Google drives quite a bit of sales, as well as quite a bit of new customers. So the first thing that we did, as I told you, is basically run the model exactly the same, but with the calibration on. And this is the result. The model is still pretty accurate. One thing that we notice is that it's not getting very well this peak, which is basically Christmas 2021. So this is quite a little underestimated, and then this one is pretty overestimated in the negative side, however. One thing that we noticed with the calibration on that we liked quite a lot is that the situation changed so much. In fact, this model we didn't like so much, because Euro USD exchange is still on top, and then there is trend, and it's nearly like 60%. This one is a little strange on the other hand. In fact, Euro USD has minus 34%, intercept as 90%, didn't like so much, but this one is actually pretty cool, because we see Google search is getting a lot more credit, and that's one thing that we completely share with Robyn in this case, because we know that Google search is a really strong channel for this client specifically, and then in fact the Euro USD lowered its impact. So we liked the calibration quite a bit, because it managed to generate a more meaningful model for our specific case. But then we wanted to test out something else. So let me open these ones as well. Here, if I'm not mistaken, we decided to take off our Euro USD exchange. In fact, because basically we didn't like what we were seeing, and we know it can have an impact on our business, but we believe it cannot be so impactful, and so we decided to take it off. And as you can see, this model really dropped down in terms of impact at first, because you see the actual versus predicted is not looking good. All the peaks are not getting basically described as good as before, and it's pretty much the same for all of them. This is a little better probably. Yeah, in fact we have an 80% of our square, and actually here is looking not too bad, in the sense that we have search at top. We don't like this intercept to be this high basically, and another thing that we don't like, just like we said before, is our Google Organic to have 0% impact. So still we think there is margin to make this model better here as well. You see that trend and intercept have a lot. So we decided to rebuild the model. This time around, the fourth time, we decided to remove a bunch of profit variables. In fact, we kept only weekday and season. We removed holiday and trend, because we believe that trend can be described pretty well by intercept alone. And we decided to remove holiday because this business is not so related to holiday. You see there is a clear peak basically in here. But another thing that's note with this business is that they get a lot less sales during summer, for instance, okay? So we decided to use season because we believe that seasonality could better represent this behavior and potentially represent the behavior where during the last part of the year, during December, basically we get more sales because there is summer, okay? There is Christmas. One thing to note, I'm talking about sales, that's true, but like we said, we are specifically modeling on new customers. The number of new customers and sales are pretty correlated, as this business work pretty much with the same amount of transaction from new customers and recurring customers. So, but anyway, we are modeling new customers specifically here. And one thing that you can see is that this model is already looking better in terms of fitting over the actual versus predicted response and in terms of variables over here. However, we don't like that the intercept gets more than 60%, and we don't like the organic Google is still all the way down here. It's cool that search is this hub. However, referral doesn't make that much sense for us to be this impactful. And we know for sure that Bing kind of has an impact. So we're not sure if we are okay with Bing having this small attributed response basically, but we have to consider that Bing has been turned off for a lot of the time during this time frame. So that's something that we can probably accept pretty well. But by looking at all of this, I'll zoom in a little for you guys to see better. You see that the intercept is always on top. And all these models again are pretty similar to each other. Basically, intercept on top, then Google search, and then there is usually either a referral, email, and then a bunch of other variables pretty equally distributed. So one thing that we still thought that we can potentially do better in this model is to remove the organic Bing, because we know that organic Bing doesn't have that much of an impact, basically. It can have an impact, but not that much. So we decided to remove that, hoping that the impact attributed to organic Bing will be basically attributed to organic Google, for instance. And so we did that into this last model. Okay, while there are a few which are not so good, like these ones, okay, this is actually overall pretty good. We have a lot of intercept, which again, let me make this full screen basically. Okay. So we again have a lot of intercept that we don't love. Let me see, there was another one like this one, where the intercept is a little lower, but in general, we are getting closer to something that makes sense for us. Google Performance Max is getting more impact, Google Display is getting more impact, Google Others is getting more impact, and from there, basically, there are still a couple of things that we will potentially do. The first thing that comes to my mind is aggregating weekly data from daily to weekly. This will make the model with a ton less variations, which will make it easier for Robyn to describe. And that's something that you can do potentially whenever you have a situation like this, okay? In this case specifically, we wanted to keep it daily because, like I said, the weekends are days where we have a lot less impact. So it's kind of more functional for us to have it on the daily side, basically. And then some things that you can do is basically aggregate all the organic variables, maybe. So we can aggregate organic Google, search referral, organic Google, organic referral, organic email, organic Bing maybe as well. So we can basically just get one macro organic session variable, which can help describe the model better instead of having that split up. Since we see that it's not quite working, this changed their impact way too much, basically. And then another thing that we can do is potentially aggregate some Google channels where we have smaller spends, basically. I will do that and show you in a second. Okay, so we moved into Google Sheets since it's quite an easy modifications to do to our dataset. And let's go with import, upload, and select our dataset over here. Then I will go with replace the current sheet since it's empty. And here's our dataset to Google Sheet. And as simple as it is, what we can do is simply add a column here, call it like organic sessions. and then go like equals S2 plus T2 plus U2 plus V2, okay? Oh, I put an extra plus, okay. Then we will autofill everything, and as you can see, going down here, we have basically the sum of all these 4 columns. And let's go with this one. Okay, so we can rename that like dataset new and go with downloads. Okay, so we got our dataset new inside our folder, and then let's move on to our studio to edit our file a little bit. So this gets to be dataset-new, and instead of having all of these, we will have only organic sessions, I believe, or session, I don't remember. Okay, with the final S basically. Then we can remove everything else over here. Let's keep it daily for now, so we keep season and weekday, and then we will keep the window. Weeble is okay. We need to update these ones since we don't need all of these anymore, and we can change this to organic sessions basically. So just like this. Okay, now let's redefine Robyn inputs. Redefine our parameters, set them inside the input collect, and then once you do that, you need to actually rerun the calibration. In fact, you need to run this again and run this again. Otherwise, once you run the Robyn inputs with the other parameters, it will basically overwrite the input collect, and you will lose the calibration information. So once we do that, we will simply run the model again, and that will get back to you once this has completed. So let's run this, and as you can see, it started to execute, and I will be back in a moment for you. All right, so our model is ready. Let's check this out. I will open all of this, and this still has a lot of intercept, as you can see if I zoom in a little. So let me check quickly which one is doing any better. Okay, this one seems to look better. In fact, if you see, Google search is on top, which is something that we agree with and we kind of expect to see in our models. Then the intercept still has a big share, but much lower than usual, and it's second place basically. Then we see Google Performance Max, Facebook, and organic session. So this really looks good business-wise for our business knowledge. The thing is, the model is not really accurate. In fact, over here you can see that we are underestimating a lot over the positive spikes basically, and we can say overestimate on the downfalls because we don't expect the down peaks to be that low. And one thing that I noticed that is the same across all these models is that the MAPI is really high. It's 95%, as you can see over here. And this is basically an error that Robyn adds whenever you introduce calibration in your models, and it's telling you basically how accurate the calibration is. And 95% of error is extremely high. So in addition to this model, I actually run the same model, so with organic session aggregated, but without the calibration. In fact, I wanted to see whether or not by removing the calibration the model would get any better, and this is it. So let's check this out. We can see this is pretty bad. I'll show you quickly zooming in, and then I will quickly check for a better model. You see it mostly given to intercept. The variations are really bad. This looks much better, but there is a lot of intercept. Let's see if we can get any better than this. Okay, so let's get one of these, which they are pretty much all similar. But anyway, you see that our R-square, RMSE, and the comparison just got better basically. The intercept still has this big share, around 40% of our total new customers are attributed to intercept. And then we can see a situation that we like basically, because we have a lot of Google search, which is basically our main spend channel, as you can see down here as well. And then we have organic session driving quite a bit, Facebook spam, Google performance, and Google others, basically. So other Google variables having a huge impact. And then we have weekday and season, which doesn't seem to have a big impact. One thing that I would like to see is weekday having more impact, either positive or negative, since we know that there is this kind of situation where we have huge reduction in new customers during the weekend and better in the weekdays. But overall, this model is really cool. One thing that we can consider is, since we see that the intercept keeps such a big share of our general new customers across our historical data, maybe, not necessarily, but maybe we may be missing out some variables. So you can talk to your team and understand whether or not there are other variables that can have an impact on your business. And specifically in this case, there is another advertising channel which we cannot get the data from, because basically there are no APIs, and this channel specifically is managed from another agency which doesn't want to share data with us specifically for this kind of analysis. And for this reason, we believe that a part of this big intercept share basically would be attributed to this other advertising channel, which has a spending which is approximately half of what we are spending on all Google. So as you can see, Google here on aggregated, we can say it takes up to 25 plus 6. It goes over 30% of the share of new customers. So if we take the data from the new channel, we can expect something like 10 to 15% of new customers attributed to the channel, and we can see a more accurate model. Another thing that we can do, like we said, if we have the case basically, is to aggregate the data to a weekly. So we reduce the variations in the data, and we help Robyn basically making this easier for them. Then once we have our kind of like a top model, another thing that we will do usually is try a bigger trials and iteration number with maybe some larger boundaries for every parameters to see if there is any margin to optimization for that. And then in the phase of choosing the top model, we will try to look with the marketing team at the estimated CPA or ROI, whether you are using conversion or revenue as your variable, and try with the marketing team, the CMO specifically, or maybe the manager of each channel, to try and figure out which CPA make more sense based on their knowledge. We don't want to see the same CPA or the same ROI that we see on Facebook and Google, because of course, due to third-party cookies restrictions and stuff like that, those numbers will be different. And usually each platform will attribute more to themselves. So here you may actually see higher CPA than what you will see on a Facebook Business Manager dashboard, basically. So we are not aiming to have the exact same values because we want the model to be kind of halfway, at least in our case, between what we know about the business and what we can discover about the business using the model. Okay, so we do not take for granted that everything that we know is correct 100%, but we try to have a model that makes sense business-wise, because otherwise the stakeholders of the client or whatever, they will not, it's tougher for them to trust you basically. And for this reason, one thing that we look at is like I said, CPA ROI estimated in this chart, in order for them to kind of make sense basically for the people that work with those channels. Those may be higher, lower than what they see in their dashboards, but at least they must make somewhat sense. And these values, based on our business knowledge, will most likely make sense. Actually, these are pretty close to what we expect to see and what we calculated already by ourselves. The response curves actually look pretty realistic as well. Search there's still basically margin to to spend, as well as on Facebook. So this looks realistic. The ad stock is actually a pretty cool insight every time we see the ad stock, because this gives us a really good idea, as you can see, for the lagged effect specifically. So we can expect that if we spend on Google others, so the other kind of campaigns as well as Google Discovery, today we may not see the full effect today, but we may see that like in 4 or 5 days. There are a lot of information that you can get out of this. And usually one thing that we do with our customer is take the outputs from Robyn's or our custom built model in Cassandra and put everything inside a customized dashboard on the Studio, which will allow them to easier navigate through the data. So as you can see here, the actual versus predicted will be in a kind of interactive plot where you see each day going with your cursor over. You can see each day what was the actual revenue specifically. This is a mock-up dashboard. It's not loading the same data that I just showed you with the model. So in this case, we modeled over revenue. And you see that the specific actual revenue per week, in this case we have weekly data, over the predicted. All these bar plots are interactive. You can go over with your cursor and see the exact numbers. We have the ad stock as well, which we can see one by one in more of a zoomed in way as well for the response curves, for instance. And then we have basically anything else that you can find in Robyn, plus a cool decomposition plot where we decompose basically day by day or week by week our revenue, and we actually show the customer exactly how much revenue is attributed to each variable. So here there was an holiday, and nearly 1 million of our revenue was attributed to that holiday that day. Overall, newsletter has a really good impact, out of home as well as TV. And so you can see specifically based on the model how much of the revenue is attributed to each channel. And then we go over with the analysis of profit. Again, these are all interactive. You can see specifically each point. This is a correlation plot. If you are curious to know what's the specific correlation between your revenue or conversions or whatever with a specific channel like print, for instance, you can select print here, and you can see that there is not such a high correlation because pretty much the more we spend on print over here on the x-axis, the response really stays the same. So print probably doesn't have a really direct impact on sales. And then on the end we have the budget allocator, just like for Robyn, but again you can go over with your mouse and just see whatever. So this was just to show you another thing that you can build potentially on top of Robyn, on top of any kind of model that you build, maybe in Python, in R, by yourself, in order to make data easier to analyze and easier to use for non-technical people. Because most of the time, yes, this data will be shown to maybe the CMO, maybe the Google manager, the Facebook manager, in order to take actions and to put these advices into action, basically. But this data must be somewhat understood by the decision makers as well. And decision makers not always are technical people. So you want them to be 100% sure of what they are seeing, to understand the data, to understand the value that the data brings to their company, so that they will kind of help you put into action whatever advice the model is giving you, over instead of kind of maybe be skeptical and try to argue whether or not it's good or bad to do whatever. So like I said at the beginning of the video, this is just how we do it in Cassandra. We would love to hear about how you guys do it for your clients, or maybe if you are not yet into the market, what are some ideas or suggestions on how we could potentially optimize our process, our outputs. That will be so cool. If you want to get in touch, for instance, with us to get consultancy, to introduce Cassandra inside your company, don't hesitate. Just go to cassandra.app, and oops, this is the admin panel. And here you have everything that you need to get in touch to understand how we work. And inside the description of this video, you will find all the information to get in touch with us and to book a call if you want to learn more. Thank you so much, guys, for watching, and see you in the next video. Bye.